Hi, so for today we are going to talk about solving exponential and logarithmic function. This is a part of our study all about engineering mathematics, board exam review, and college algebra. So let me start first by giving a property of the exponential function. If b raised to x equals b raised to y, then x equals simply y. So what this property means is that if we have the same base b, we call it base. Okay, if we have the same base, we can actually equate, okay, their exponents and solve for the necessary value of whatever is being asked in the problem. So let's have an example here. We have 5 raised to 3x equals 5 raised to 7x minus 2. Now notice they have the same base, which is 5. Okay, so this is the same base. So technically, we can apply the property such that we have 3x equals 7x minus 2. Then we're going to solve for the value of x to find the value of x that would make this equation equal. So we have 7x minus 3x equals 2. So that's 4x equals 2. Solving for x, we have 2 all over 4, or basically 1 half. So this is the value of x that would make this equation equal, as it is being asked that we have to solve for the value of x. Now, another example is it's not only limited to the values of uh, or to the variable x and y, but we can also have any other variables in our exponent, such as this example. We have the uh, variable t. So this is our base. They have the same base. So therefore, we can equate them. T squared equals 6 minus t. So this would result actually in a quadratic form. So we have t squared plus t minus 6 equals 0. So we only have to factor this one. So we will be finding two numbers that when we multiply, it will result to negative 6. And if we add, it will result to positive 1 because the coefficient of t is 1. So that would be t plus 3, okay, and t minus 2. Of course, if we multiply positive 3 to negative 2, it's negative 6. If we multiply, or if we add positive 3 plus negative 2, would be positive 1, which is the correct factored form of this. So this would be t equals negative 3 and t equals 2. So that would be our two answers that would be the right values for the values of t for this equation to be equal. So for letter C, we have 3 raised to z equals 9 raised to z plus 5. Okay, as we know, we cannot directly use our property that we have studied a while ago because they don't have the same base. But actually, 9 is actually a factor of 3. So we can rewrite 9 as 3 squared. That is 9 multiplied by 7 plus 5. Z plus 5, I mean. Z plus 5. So, it means they already have the same base, which is 3. So, we can apply the property. So, we have Z equals 2 times Z plus 5. So, we have Z equals 2Z plus 10. Of course, we have to solve for this. Negative 10 equals 2Z minus Z. So we have negative 10 equals z. So the value of z should be negative 10 for this problem. For number 4, we have letter D. We have 4 raised to 5 minus 9x equals 1 all over 8 raised to x minus 2. So the very first thing that we're going to do here, we know that they don't have the same base, and the right side of the equation is in fraction form. So using the properties of exponents, we can actually rewrite 1 all over a, let's say, raised to x, where a is any constant number, into a raised to negative x. So that's what we are going to do with our one side of the equation here. We're going to get the reciprocal, but we're going to get the negation of the exponent so that we will be avoiding the fraction form. So you have 4 raised to 5 9x equals, we have 8 raised to negative x minus 2. So we negated the exponent because we get the reciprocal. Okay? So first, I have to distribute this negative sign. So we have 8 raised to negative x plus 2, or that would be 8 raised to 2 minus x. 4 raised to 5 minus 9x. So what are we going to do is we're going to make them as the same base. And 8 is a factor of uh, 2 and 4 is a factor of 2. So I can rewrite this as 2 raised to 2, 5 minus 9x. And this would be, I have to make them the same base. So this is raised to 3 because 2 raised to 3 is 8. So we have 2 minus x. And now we can now solve. They have the same base, 2. And now I can equate them to solve for the value of x. Okay, so let's now solve for the value of x. We have 10 minus 18x. We have 6 minus 3x. We just have to distribute. Okay, so we have 10 minus 6. Transpose it here. And this negative 18, transpose it here. So we have negative 3x plus 18x. So that's 4 equals 15x. Solving for the value of x. So we have to divide this by negative 15, or 15, I mean. So you have 15, all over 15, cancelled. So we have the value for x as 4 all over 15. This would be the value of x that would make the equation on both sides true. Pretty cool, right? So let's go now to the logarithmic equations. This is just a short video, okay, all about logarithmic. So if we have log of x with base b equals log of y with the same base b, okay, then we can actually equate x equals y. So that's what we need to understand here in the logarithmic function. So remember that this b is the base. Okay? So if they have the same base, technically we can make them equal. So for number 1, we have 2 logarithmic of the square root of x with base 9 minus log of 6x minus 1 base 9 equals 0. Okay. So probably they have the same base, which is 9. So we can apply this formula. But before applying that formula, making sure that we've simplified the logarithmic, okay, through the logarithm function or properties. So as you can see, we have 2 here. And this 2, whatever is the value of the constant outside of the logarithmic sign, can be inserted here as the exponent of the square root of x. That is the property of logarithmic, wherein we have, for example, a log of b, or log of x with base b. It can be rewritten as log of x raised to a with base b. So in this type of property of the logarithm, this a is the 2. Okay? So we can rewrite this as logarithm of the square root of x squared. Okay? With base 9 minus logarithm of 6x minus 1 base 9 equals 0. So technically, the square root of x would cancel. Okay, the square root. So we have log of x with base 9 minus log of 6x minus 1 base 9 equals 0. So this is now already simplified. So we can now apply the property that we have discussed a while ago, that if they have the same base, which is 9, we can actually equate this log or value of log and this value of log. So upon equating these two, so what happens is we have x minus 6x minus 1 equals 0. Okay? So taking note that this 6x minus 1 still has the minus here. So we have to distribute the negative sign. So we have x minus 6x plus 1 equals 0. Okay? So that we have negative 5x plus 1 equals 0. So negative 5x equals negative 1. So multiplying both sides by negative 1, this will yield to 5x equals 1. Okay? Or solving the value of x, divide both sides by 5, we'll have 1/5. So that's the value of x that we are trying to solve, okay, upon our logarithmic equation. So for number 2, we have log of x plus log of x minus 1 equals log of 3x plus 12. Now, it is understood that when a logarithm does not have any base here, it's understood that it is base 10. So, of course, these are all base 10 because it does not have any value written as the base. So, again, it's understood as base 10. So, before we try to actually solve this, let us first simplify the given logarithmic. So, we have here a plus for the two logarithmic. So, there is a property in logarithm that if we have log of A, let's say base 10, this is base 10, and log of B plus log of B, we can rewrite it as log of AB. So, in this case, we are rewriting that as log of x times x minus 1 equals log of 3x plus 12. Okay? So that will be the simplification of the logarithm. Now, since they have the same base, which is 10, we can drop off the logarithm, and we simply x times x minus 1 equals 3x plus 12, then solve for the values of x. X squared minus x equals 3x plus 12. Combining like terms here in our left side of the equation, so we have x squared minus x minus 3x minus 12 equals 0. So we have x squared minus 4x minus 12 equals 0. So we have two possible values for the x, and we have to make sure to get those two values. So we have to factor this. We have x, okay, minus 6, and then x plus 2. Because if we try to multiply negative 6 and 2, positive 2, that would be negative 12. And if we add negative 6 plus 2, that would be negative 4. So we have values of two possible values of x. We have x equals 6 and x equals negative 2. Okay? But we need to test if these two values would actually be really okay with the domain of the logarithmic function. Okay? So we have to test because if you may recall, we cannot have any negative inside the logarithmic. So if we are to check, we have x equals 6. So substituting to the original value, we have log of 6 to the original value or to the original given here. Okay. We have log of 6 plus log of 6 minus 1, log of 3x plus 12. So we have 3 times x plus 12. So let's see, we have log of 6 plus log of 5. Then we have log of 18 plus 12 is log of 30. Okay? So, since the substitution of the value of x equals 6 does not yield any negative numbers inside the logarithmic, then it is a root. So, simplifying further, we have log of 5 times 6. Remember the property that we have studied a while ago. Okay? If we have a plus, we can use the property of logarithmic of a plus logarithmic of b equals log of ab. So we have 5 times 6. So log of 30 equals log of 30. So that's acceptable. The value of x equals 6 is an acceptable value for the value of x. How about for the value of x equals negative 2? So we have log of negative 2 plus log of negative 2 minus 1 equals log of 3 times negative 2 plus 12. Okay? So this is not a solution. Why? Because upon substituting the value of x, we can see right here that this yield to an inside negative value which is unacceptable to the logarithm. Even if you try to have calculator of log of negative 2, it will give you an answer of math error because this is not found in the domain of uh, uh, the logarithmic function. Okay? So here is your assignment. An assignment for you. Solve ln of 10 minus ln of 7 minus x equals ln of x using the same property that we have studied a while ago. But a hint, since this is minus, you'll be having a property of ln of a minus ln of b equals ln of a all over b. You're going to use this. Okay? So let me know down below your comments or your answers in the comments section. Okay? So thank you so much guys for listening. I hope you learned something for today's video about the solving exponential and logarithmic function as a part of our study in engineering mathematics, board exam review, or even in college algebra. So thank you so much guys and God bless.